हैं जो कि डिफरेंट एग्जाम्स में आ सकते हैं. ओके, so let's start the aptitude series, and first is percentage, and first is the basics of what is percentage basically. So if I have a particular value, okay, and it has been obtained, value obtained, okay, divided by the total value into 100. This is basically what is the meaning of percentage, is that if you have a particular value, you obtain a value particular by a like you obtain a certain marks. Suppose you obtain 80 marks out of 100. Okay, so what you will say that you how much you receive in percentage, you just multiply this with 100. Okay, so you get 80. So 80% is the marks what you receive in a particular subject, or so you scored that out of 100. So now let's start with the division. So this is the very important. First, if A is X percent more than that of B, then B is less, of course, than A. So how much percent is B less? Okay, so we have the formula basically. We know that A is X percent more, that means X upon 100 plus X into 100. Okay, this percentage B is less than A, this much percentage. Okay, now similarly, if X is X percent less than B, what was the case here? That A was X percent more. Now here is the case that A is X percent less than B. Okay, so definitely B is more value, like A is less than B, as you can see. Then B is what percentage B is more than A. Okay, so here you have to remember it's something like X upon 100 minus X into 100. Okay, calculate this, you get the value in percentage, that how much times B is, like at what percent B is more than that of A. Now here one very important thing what you notice, that if X was greater than X percentage, we basically want a smaller value. Okay, B is less, we want a smaller value, you divide it with a greater amount of denominator. For remembering, I am saying, and this concept we will use in different places. Okay, so we want a denominator which is greater in value, whereas here we want B to be more. So how do we get a greater value? When your denominator is smaller. So this is 100 minus X, here it was 100 plus X. Okay, so just for remembering that, many times people get confused, but it's quite simple. If you want more, like more percentage value, you basically know that the denominator should be a smaller value to get a bigger, more value. Okay, just for remembering, it's just a trick. Okay, now if this is a second type of thing what mostly you can see, or formulas are basically direct questions comes. So if A is X percent of C and B is Y percent of C, okay, then the case appears as that this is the case which appear that A is, now what is the relation between A and B? Like A is related to C, B is related to C. What is the relation between A and B? What percent times of A is B? So it is like A is equal, how can you calculate? A is equals to X upon Y into 100. A is this much percent of B. Okay, now third type. Now if the price of commodity increases P percent, okay, then the reduction in consumption, what percentage of consumption you will reduce, so as not to increase the expenditure. Our expenditure is constant, but the price of commodity has increased to a p percentage. So how much consumption should I reduce? What percentage of consumption should I reduce in order to maintain my expenditure? My expenditure should not increase. Okay. So what is the formula here? Here is P upon 100 plus P, okay, this into 100, this much percentage. Okay, so you should reduce your consumption to this much percentage. Okay. Okay. Now if this is the second case, if the price of commodity, now here the price of commodity has decreased by p percentage, okay, then the increase in consumption so as not to decrease the expenditure. Okay, now when the commodity price has decreased, so you can get that particular thing in a cheaper price, but you are having a fixed amount of budget that you will be expanding, like you will be buying that thing for, like you have a particular amount which you will buy. So how much increase in consumption will happen? Okay, how much you will what percentage you will get, get that thing by what percent, even though the price decreases. Okay, just opposite of the previous case. Here the price of commodity has increased, so how much will be the reduction in consumption, whereas here is the price has decreased, so how much percentage more can you consume in that same amount of expenditure. So what is here, how much percentage you can increase? It is nothing but P upon 100 minus P, okay, into 100%. Now in both of the things there is something common. Just before that in first case I explained that if you want less, okay, if something is coming less, you increase the denominator value, you add 100 plus x, okay, and when you need more, what you will do, you will try to decrease the denominator. So can you see the same pattern here also in commodity type, that when you have to decrease, like it was asking that you have to reduce the consumption. So what you are doing here, same thing, that you are increasing the denominator, and same thing when the consumption has been increased. Okay, so by what percent are you increasing? So here what you are doing, you are increasing the value, decreasing the value of denominator. You are putting here 100 minus P. Okay, now fourth, so if a number is changed, that is increased or decreased successively by x percent and y percent, then what is the net percentage change? Okay, so how can we know about that? It is nothing but x plus y plus x y upon 100. Okay, in percentage. Now suppose it is increasing, okay, the first value is positive, so here we will put in front of x plus. If second value is decreasing, then we will put here minus, like you will put the you don't put the magnitude value, you put with the sign, then this particular change, suppose if both are decreasing, both are minus minus, so you will put here minus minus, and you will, then here by default you will put plus, but this will come in a decrease, so net there will be decrease. So how much percentage net is the decrease? Okay, now the fifth is, if the present population of a town, okay, this is very common type which you will see. So if the present population of a town or value of any item, suppose, is P, and the population or the value of item changes at R percentage per annum, then the population, there are two cases, the population or the value of item after n number of year and before n number of years. Okay, so you know the current situation, you know by what rate it is changing. Now you have to determine that after n numbers of year what will be the population and what was Okay, this too you can determine. So that's a simple formula, P into 1 plus R by 100 to the power of n. Okay. Similarly, when you have to determine for back, like before n years, what was the population, so you will divide it, 1 plus R by 100 to the power of n. Okay. So you'll get the value of that particular value of an item or the population. This is forecasting. Okay. You can predict for future as well as you can calculate, like for the previous you can calculate. Okay. Now the sixth is, if a number a is increased by x percentage, y percentage and z percentage, okay, successively, then the final value of a will be, okay. So this, how you can determine that what will be the value if it is continuously been increasing by x percent, y percent and z percent. Now here also, like let's first see the formula. So if you are increasing, so what will be the value of a after all these increments? 1 plus x by 100 into y, 1 plus y by 100 into 1 plus z by 100. Okay, let me remove this bracket. This is little not in a, okay. So this will be the value of that a after x, y and z changes. Okay, now one more thing here. What if this is decreasing? Then we will put the minus sign with that, like minus x, minus y. Suppose they are all decreasing, then and then we will respectively put the values here, and then we will get the value of successive decreasing. After successive decreasing, what will be the case? Okay. Now the seventh and the last, what mostly is been asked with the respect to the percentage or this. So this is very simple. Now conversion of a fraction into percentage. So suppose there is a fraction of L by M or anything, you just multiply with by 100 and you will get the value in the percentage. Okay, not a big deal. Or second is like, if something is given in percentage and it's asked in fraction, so what you will do, you will just suppose let's take a small example, like you have 16 2 by 3. Suppose this is given in percentage, 16 2 by 3%. Now it is asked what is the fraction value of that. So what you will multiply, you will just multiply here 16 into 3 plus 2, so this will be 50. So 50 by 3. Okay, just divide the whole thing with the value of 100. Okay, here you were multiplying the thing with the fraction with the 100, here you are dividing that thing with the 100. Okay, so what you will get the value? 1 by 6. So that is the conversion from percentage to fraction. Okay, now to find the percentage of a given number, suppose you are given a particular number and it's asked that what is the percentage of that. Like let's take one example. Okay, just for now I will take like in this value. Suppose x percentage of a given number n is what? So that is x by 100 into n. Okay, now from here let's see some of the problems which are basically nothing